I'd like to take a little bit of account of what ground we've covered so far in these videos. This is number 22. This is June 28th. Okay, let's see what do we have under our belt so far through these, or what should we have? I have already shown in these videos how magnets have been misinterpreted, which has led to the belief in negative charge, which doesn't exist. I have already shown as well why, contrary to the equivalence principle, objects with different masses given enough drop distance and mass contrast will fall not at the same rate through a vacuum of space or Earth's atmosphere, through the medium of water, as well as balls of differing mass not rolling down a sloping track at the same rate. That can be repeated. Those can be repeated. If you try to say that those don't apply to the vacuum space, you're wrong. They do. That's all artificial. The world we live in is like the atomic world. These are naturalistic explanations. This is what we need to aspire toward. Our naturalistic explanation, not supernatural explanation, not artificial, not cheap substitute explanations that we can't find just because we fail to find them. It has been demonstrated in these videos that there is no way to reconcile the difference in density between materials like lead and graphite using the periodic table's assignments for electron mass, which then requires the mass of the number of nucleons contained in the same volume, structure versus similar structure, which in no way works out, which falsifies not the sequence of the elements, of course, in the periodic table, and the great work that's been done in so many respects with regard to that and many other things we use every day, but the negative charge, positive charge basis and its allocations for those elements as that is assigned. Another thing not mentioned yet in these videos is one of the 5 maxims or axioms, you might call them, of quantum mechanics, which states that, I quote, "The atomic world is nothing like the world we live in." If that isn't word for word, it's very, very close. When I came out of religion and saw that, I said, there's some big problems here that need to be changed. This is also horrendous and false, even though science has used quantum physics nonetheless as an underlying conceptual basis for most of the past 100 years. Even as my non-negative charge system makes everything in the micro and macro correspond and mirror one another, you can definitely conclude, therefore, that quantum mechanics and a good number of the concepts used in science right now, even though useful applications have arisen, have been nevertheless managed despite those. Those are not naturalist. They are not truly naturalist explanations. They are not naturalist explanations. Those are more akin to those that are clinged to by those relying on supernatural and artificial, superstitious explanations. When you don't understand something, you always use an artificial or supernatural or superstitious explanation. We still have those in science today. I'm sorry to tell you. We can do better than that. It's not enough to just accomplish applications, we need to understand reality thoroughly. We need to aspire toward that. That's what this effort is. This effort represents what needs to emerge as a movement away from all supernatural or artificial type explanations toward purely naturalistic type explanations for every single thing that occurs, so that we can not only eventually rescue the public from the mental abuses of religious faith and society from its associated harmful effects. You know, religion, when it sells itself to the public, it presents all these things: everlasting life, immortality, it promises, morality, some sort of structure for morality. All these supposed positives, but it has many negative things that it causes, and we can do much better than that. But we can also, by taking this approach, we can improve science as well, which needs to happen. Today, if I get around to it, I'd like to explain something about conductors. Well, let's go ahead and mention that. I'm going to jump around a little bit. Let's see. Looked up, I Googled elements that make good insulators. Now, this is something I've been needing to work on. And I need to be able to explain through my system why some materials make good insulators and others are good conductors. Of course, copper is a good conductor. When you Google elements that make good insulators, here's what you come up with. Conductors conduct electric current very easily because of their free electrons. Okay, well, that's what the standard model is telling us right now about electric current. Of course, my system is set up differently. So I'm looking for another explanation than what we have right now. Insulators oppose electrical current and make poor conductors. Some common conductors are copper, aluminum, gold, and silver. Some common insulators are glass, air, plastic, rubber, and wood. Now notice, in the insulators, there's no elements mentioned. Now, graphite is a conductor. It's not a very good conductor. If you take the graphite of a pencil and hook it up to a strong battery, a high voltage battery, with a electrode attached to each end of the lead and a pencil, remove the wood, it will glow orange. There's photons in the material that reach light speed and come out as red light. It glows red. That's how you make a heating element. You need resistance. There's resistance to electric current in some materials. And in other materials, there's not as... This, right now, that doesn't look like that's caused by the number of protons or neutrons on the surface of a nucleus, or by the element itself, as much as the structure, the molecular structure of a material. Or if you're talking about an element, then you're talking about the difference in what is called allotropes, individual elements with no other materials mixed in, sometimes take on a structure rather than amorphous, which they just pile on. The atoms just pile on one another. When it's amorphous, there's no structure. So what looks to be happening is that these materials that have openness in their structure, this causes resistance, like glass, like air, like plastic, like rubber, like wood. Now, we know that lightning passes through the air. It jumps from gas molecule to gas molecule. It couldn't do that without those molecules. Those molecules are where the electric photons are loaded around the nucleus. Okay, and you have the other orbiting, hovering particles. Now, all that has to be worked out exactly how those transmissions occur, how electric current flows. I've got some ideas going on that, but you know, with the structures of the atom that I've come up with and have seen and interpreted from atoms lensing in direct sunlight, atoms attached to cotton fibers that you can see in direct sunlight. By the way, let me mention something else about that. When you see a gray area, it looks like a gray sphere around the nucleus of an atom. In that, when you do that, the reason it's gray is because some photons apparently are able to make it through. Some photons of light from the sun, it's very concentrated when you look at direct sunlight, are able to flow through those shells. That's why it's not black. Like the circles where the electrons that are orbiting outward from that gray sphere is, those are all black. But the shells, the radio shells that are stacked and spherical and filled, there are some visible light photons that manage to pass through those, which keeps it from being completely blocked, or they would be black. That area would be black. There's a couple of other things about that I would like to mention. Lightning. When lightning is passing from molecule to molecule through the atmosphere, what you have is a tremendous buildup of electric loading caused by friction in the atmosphere, wind against the clouds, this kind of thing. You have that also in volcanoes, where the clouds of dust material come up, and there's a lot of disturbance and friction, and there's lightning. Okay, that friction is the same thing in principle as what happens in a dynamo. Whenever you take a rotor, and it's not going to take on of copper, and it has copper wire running out from it, which is a great conductor, it's not going to do anything. You're not going to have any increase of electric current, which can be passed down the lines, unless you turn the rotor. Why? What does the turning of the rotor mean? Now, I understood this, not perfectly, but I understood it when I did the first book. You have to turn it because this disturbs nuclei surfaces. This disturbs the radio shells. More so, what I would say now is it disturbs the radio shells. The other thing I wanted to mention while we're going through this is that the radio shells, now in quantum physics, the way light comes off of a material is a photon has come in to the electrons surrounding a nucleus, and then they're absorbed, and then the electrons emit a photon. Okay. In my system, they just bounce. What is shaping up to obviously be the explanation, and I've already referred to this in my writing prior to this, ever since I got my atom model together, my bases with these radio shells, then the electron shells out from there. What's been coming into focus is that the radial shell area is what's deflecting the photon. That's where the visible light is hitting, and there might be some cushioning because there's repel holding those shells, particles in those shells where they are, but even repel can help photons jump to light speed. Just by the thrust of repel can up a velocity, but those shells, now they would be vibrating. So keep in mind too that as they vibrate, one that hits it and causes it to go in, the next one hits it when the photon is recoiling, or the radio particle recoils and is going back out, and then there's a collision. There you have the bouncing. Lightning. when lightning is passing from molecule to molecule through the atmosphere, what you have is a tremendous buildup of electric loading caused by friction in the atmosphere, wind against the clouds, this kind of thing. You have that also in volcanoes, where the clouds of dust material come up, and there's a lot of disturbance and friction, and there's lightning. Okay, that friction is the same thing in principle as what happens in a dynamo. Whenever you take a rotor, and it's not going to take on of copper, and it has copper wire running out from it, which is a great conductor. It's not going to do anything. You're not going to have any increase of electric current, which can be passed down the lines, unless you turn the rotor. Why? What does the turning of the rotor mean? I understood this, not perfectly, but I understood it when I did the first book. You have to turn it because this disturbs nuclei surfaces. This disturbs the radio shells. More so, what I would say now is it disturbs the radio shells. The other thing I wanted to mention while we're going through this is that the radio shells, now in quantum physics, the way light comes off of a material is a photon has come in to the electrons surrounding a nucleus, and then they're absorbed, and then the electrons emit a photon. Okay. In my system, they just bounce. What is shaping up to obviously be the explanation, and I've already referred to this in my writing prior to this, ever since I got my atom model together, my bases with these radio shells, then the electron shells out from there. What's been coming into focus is that the radial shell area is what's deflecting the photon. That's where the visible light is hitting, and there might be some cushioning because there's repel holding those shells, particles in those shells where they are, but even repel can help photons jump to light speed. Just by the thrust of repel can up a velocity, but those shells, now they would be vibrating. So keep in mind too that as they vibrate, one that hits it and causes it to go in, the next one hits it when the photon is recoiling, or the radio particle recoils and is going back out, and then there's a collision. There you have the bouncing, the inward movement interval in the vibration, but the outward movement, when the outward, of course, a lot of the photons, visible light photons coming in, will miss and manage to pass through, or collide with other shells inside and bounce around and fall down, what have you. But what I would say, and I would adopt this until someone can overthrow it, that it's when these shells are vibrating, and when they're vibrating, they're moving in and out real fast. And when they're moving in, and a photon has collided to cause it to move in, or something else, that's not going to bounce light well. It's not going to work. But when one recoils back, now you have the making of a really strong, powerful collision that's going to this is going to not only give the incoming particle, help it retain its velocity, but it's going to even perhaps boost it. And this would be responsible for the different colors of all the materials. Is what radio shells are present. Some of those will be filled, that are the outer shell. Some of those will be partially filled or very scant. And then so another shell under it. And then how those bounce light, that's responsible for all the colors. Okay. That would be where you have bounce light. Like when you look at the moon, and you see the sun's light bouncing from it, that's what you're seeing. You're seeing photons bouncing from the radio shells. They're not going to make it all the way down to the nucleus and bounce out. That's not going to happen. The nucleus is very small in comparison as well. But these radio shells are substantial and they're big. And there you go. I want to explain some more stuff about this because this is in my first book. I was trying to figure out, I'll just tell you a few of the mistakes I made in the first book. I was trying to figure out what was in a proton. How many, I didn't know about J.J. Thomson yet, but I think in this proton rather, I was coming up with numbers like 3,000, something like 3,000 photons in a proton. Later I adopted J.J. Thomson's numbers when he said there was the mass of the particles or whatever it is in the emission of it comes out of cathode ray guns as 1836 the mass of a proton. That's so far that looks like a really good number, but I was way off starting. I was just trying to understand repel and attraction. My system was set up without negative charge, so everything had to be repel and attraction. And the digits, I was just trying to digitize everything. So this is a early drawing of a proton when I didn't know what the proportions would be. When you skip over a few pages, here's an early electron I was drawing. I had my 6-particle system at the time had a black, a blue, a green, a yellow, and a red and a white. Of course, I still have those in my 13-particle system, but there's other charges in between those. You have to have those to explain everything. Anyway, you can see this was done, if these were electrons, which they're not. But this, in principle, this is what I still do. I only had a 6-particle system, so the red was there you go. There's your high charged interior photon, covered over by blues. There's a couple of blacks, I think, on this one. So you have that charge contrast. They attach, and then now you need something to cover the blacks and blues because they're not copacetic with the environment. So then you have the yellows attaching to those. Of course, those are precarious and they wouldn't last in the environment where there are a lot of collisions. But I was working on this back then. I was headed in the right direction on this. If you're going to approach everything as a naturalist like I do. Now this is funny. This is the next page because I really had that messed up. Now there's a black in the center, and I didn't even know yet that, well, of course, those yellows repel. That was my electron, let's see. The real orbiting electron. I didn't really, what you have with that, and I wasn't even there yet, is you have a black in the center, if that was, one of the electrons, and it might be, but, and then you have a yellow on top and on the bottom, and then you have a yellow on this, that would be, let's see, X, Y, BY, you'd have top and bottom. Then on the sides, that would be Z. Then you got two more this way. This would be, let's see, Y, the Y direction. And those would have to be like I draw them now because they can't touch because they repel. They can attach to the very strongly attracted black or dark blue. But now with the dark blue, there would be fewer of them that could attach because the attraction is not as strong. So when you're looking at some of my radio particles, you wonder, okay, why does this one only have 5, instead of 7? And well, when you get up, like just say you have an R7, it's harder for those to be yellows because the yellows repel one another more. You throw in a couple of yellow greens, now it's going to work a lot better. That's how that works. But in this picture, I didn't even know yet that that they would, how they would arrange as spheres upon spheres, with repel and everything. I wasn't there yet. Now I was really confused. This is one of the next pictures. I was really confused here, and this is, I would hold the standard model responsible for my confusion. I've worked things out in a naturalistic way now. I just need to fill in the details, explain, what's going on with conductors versus insulators, things like that. Refine how electric current flows. All of that. That's all going to come. I've got some progress in those areas already, but those are areas I still need to work on. But what I was struggling with at the time when I drew this was I was trying to take what the standard model gave as far as the mass of an electron. Now, when I was first starting out almost 10 years ago with this, the idea was that, well, you could read in some places on the internet back then that electrons didn't have mass, and then some places say they do have mass, and they didn't seem like everything was settled on that. We now know, if you research it more thoroughly, because I'm required to come up with naturalistic explanations that mirror the natural world we live in every day. That's what the problem was here. I had the idea that that if electrons were out from a nucleus, that they would have to orbit in the same direction. That's what these arrows are about, and you could get that to happen in a material where the atoms are up against one another if you have the electrons turning and side by side, turning in opposite directions. That's some of the stuff I was working on. And then, of course, the standard model says that the electrons encase the nucleus. And so that's kind of what was going on here. At first I had, okay, if that's what they think's going on, then the electrons there might be different, like, latitudes of them orbiting. But they would have to go in the same direction. You couldn't have them you just changing directions randomly, I didn't think. And as they have drawn it now, or have depicted now in the standard model. But anyway, more importantly is, if you have, okay, these are supposed to be nuclei, and my system, what I was trying to come up with was, why would these particles that have repel, okay, if you have the surfaces of these nucleons that are attached, if the surfaces have repelling particles, and you can see that in my proton. Of course, now I've got greens on the outside, but you have the blacks in the center there. No, there's whites, then blacks. Whites are in the center, then blacks around those, then reds, then blue, then yellow on the blue. See, still charged contrast is causing it. Then you have greens on the outside, but that's an early version. What I was doing here was, I was trying to envision a way that you could get repelling particles on the surface that had enough repel, so that some would need to orbit. That's still part of my system. Now, this is a very crude drawing. It looks silly, but because I was being a naturalist, and I required that everything makes sense. You just couldn't have magically equal mass electrons out of different shells, or that's like magic. There's no good explanation for that. Nothing in the natural world would explain that. You're going to say it happens just because you're like God, or you don't know how it works, so you say that, and then whatever. But in this system, the reason these are so close is because if these electrons would just have such little mass that they're assigned, if they were a single photon, let's say, then they would, the repel from each one wouldn't extend out into space from it very far. And so it couldn't be way out here or way, way, way out there because it's there's no reason, nothing to hold it out there. Its repel wouldn't extend that far out. So it would have to sense the repel from the surface, and it would have to have and that repel from its own unit, its own single digit. And so that's why those are so close. Of course, you know, if you put another shell, why would you have another shell out from that? Because it wasn't even thought that electrons could have varying masses that cause them to orbit farther out. This is something I came up with later as I continued to work on this. But this was early on, and I was just trying to see, okay, why would these orbit? Why would they not attach? Why would they hover? Why would they orbit? And where would they orbit? They would orbit very close. And that was an early stage of this. Now I'll go ahead and say this about conductors. Conductors, if you look it up, they're not an element. We don't need to explain conductors by nucleon proportions, proton-neutron proportions on the surface of a nucleus. Considered that for a while. It's not necessary. It's all going to be explained, looks like, with simply spacing the structure. Carbon, I already mentioned, carbon is a conductor. It has some resistance, so it heats up when you use it. But it conducts electricity. Just about everything conducts electricity. Water conducts electricity. But it's going to be the structure of carbon atoms and some of the materials it makes is very open, very open. You can see that is depicted, in scientific documents or on Wikipedia or whatever. You see these structures that are very open with carbon. Carbon's very strong. It can make a very strong material that is also very light. It's very light because it's very open, and it attaches in certain ways, depending on what it's subjected to when the material is being produced, the processes, all of that. But carbon is involved in plastic. Plastic is a great conductor. It's like this. If you have a spark plug, and its gap is, say, something like that, and the spark, you got a buildup of electric loading here, and it jumps across. The spark jumps and feeds around, makes a circuit. Now, if you move the probe apart too far, it can't jump. There's too much space, and that's what you're going to have in principle with insulators. This is not going to be a certain element necessarily, though some materials and some elements resist electric current flowing through them more than others. It's mainly going to be just the space, the structure, like with glass, and all the things it mentioned. Let's see, I'll pull that back up. Glass, plastic, rubber, wood, those are all open. There's a lot of open spacing there, and that's it. It's just the idea of, like you have with the spark plug. Or now another thing is, the more buildup you have, which has to do with voltage, potential energy, electric energy to jump across a gap, or with lightning in the atmosphere, if you have a tremendous buildup, then it'll trump the insulation qualities of air, for example. So if you had a greater buildup in a spark plug, you could move the gap farther apart and it would jump across. And so this is what's going on with insulators. And so it doesn't need to be explained with the number of protons and neutrons on the surface of a nucleus, or it doesn't, you know, there might be some there might be some remote relationship to that, but that's not at all the main thing, or even it at all. You don't just have some elements that are conductors and some that are insulators. It's about openness. It's about space, too much space, and then of course voltage levels. So I wanted to start getting into that more. Mention that here. Thank you. Two more items I forgot to mention that have been falsified in these videos is GPS needing relativity's time dilation to be accurate. That's one of the key points in these videos so far. Another one is that Mercury's orbit needs anything other than sun wobble to account for its orbit, its perihelion precessing. That is really straightforward, that it's sun wobble causing that. So if we're going to do some accounting of what has been mentioned in these videos, discussed, and really, I think, proved, I think these two items need to be added, and I didn't mention that at the beginning of this. Thank you.